Hello class, today we are going to talk about circles on the coordinate plane. So we're looking at circles on the XY coordinate grid, the Cartesian coordinate plane. And mostly what we're going to be doing is looking at the equation of a circle. So this is the standard equation of a circle. It is x minus h squared plus y minus k squared equals r squared. And with this is derived using the Pythagorean theorem because the radius is the same all the way around, and so usually it's the distance formula, and the distance formula is going to be the same all the way around no matter what k or y, x or y is. It's going to be the same. And so the way this works, h and k, that is the center of your circle, and the radius is r. So whatever circle it is you want, this is the formula. X minus the x value of the center squared plus y minus the y value of the center squared equals the radius squared. All right? So let's take a look at a couple of these. So first we're going to write the standard equation for this circle, and then we're going to write one for this information. So on A, circle shown at the left, we need the center is 0, 0 at the origin, and the radius is 3. So what we're going to do is we're just going to plug that in. Here's our standard equation. Our center is 0, 0, so we put 0 in for h, we put 0 in for k, and our radius is 3, so we put 3 in for r. Simplify this, and we end up with x squared plus y squared equals 9. All right? And there's the equation for this circle. Now we're going to write the equation for a circle that has a center at 0, negative 9, and a radius of 4.2. So again, here's our there we go. Here's our standard equation, standard form. We'll plug in for the center, 0 for h, negative 9 for k, and we plug in 4.2 for r. So we have this. Simplify this. X minus 0 is x, y minus negative 9, so y plus 9 squared, equals 4.2 squared, which is 17.64. All right? And there is the equation for that circle. So this is really pretty simple, not very complicated at all. Now, unfortunately, you can't graph this in most of your graphing calculators. There are some softwares like Desmos or GeoGebra or something like that that will do it. But most of your graphing calculators won't graph these because they're not functions, right? That doesn't pass the vertical line test. So what I want you to do is come up with the standard equation for these two circles. Pause the video, work these out, then come back and check your answer. All right, let's see how you did for number 1 and for number 2. So if you got these, great, you can skip ahead a little bit. If not, number 1, we're going to take the center, 0, 0, plug those in for h and k. We take 2.5, plug that in for r, and so we have this. Simplifies down, we have x squared plus y squared equals 6.25. All right. On number 2, this gets plugged in for the center, which you can see there. 7 gets plugged in for the r, so we're going to square that. Now remember, this is a positive because it's a negative there, and it's minus h. Basically, anything in parentheses is going to look backwards. All right. So this is negative, so it looks positive. This is positive, so it comes out looking negative. All right. So what we're going to do here, we have the point negative 5, 6, which is on this circle. We have the center at negative 1, 3, right there, and we need to come up with the standard equation of this one. Well, we've got the center, so we've got h and k, we just need the radius. And to come up with the radius, basically what we're going to do is we're just going to find the distance, use the distance formula here. All right, so the distance formula gives us radius, and if you'll notice, this is really nothing more than the formula for the circle. It's just instead of having r squared, it's r and the square root of everything. So this is just the formula of the circle. We're solving it for r. So we plug in x and y right here from the point that is on the circle. This is our center, this is our h and k, and then we just solve this. And you can take that, work it out, and there it is. So radius is 5. So the equation of the circle, we substitute this all in. Here's our standard form. h is -1, k is +3, and our radius we now know to be 5. So there's our equation. All right. Nice and simple. Not too bad. So now this is slightly more complicated. Here we need to find this is the equation of some circle, obviously not in standard form, right? So we need to find the center and the radius of the circle, then we're going to graph it. Now to find the center and the radius, we need to know what this is in standard form. All right? And what we do to get that is we're going to complete the square. Right? For those of you who remember that from Algebra 2 and stuff, solving quadratic equations. Step 1, we write down our equation. Next, we're going to isolate the constant. We're going to get this 16 to the other side. So we add 16 to both sides of the equation. And what we're going to do is we're going to group all our terms. We're going to put all of our x's together. We're going to put all of our y's together. And now we complete the square. We're going to complete the square twice. Complete it once for the x's, once for the y's. For those of you who don't remember how to complete the square, basically all we have to do for the x's, we take this -8x and we divide -8 by 2 and then square it. So -8 divided by 2 is 4, squared is 16. We're going to do the same thing with the y term right here. So 4 divided by 2 is 2, squared is 4. And we add the 16 in, we add the 4 in, and we do it to both sides. So we add 16 to both sides of the equation, we add 4 to both sides of the equation. Then, what we're going to do is we're going to rewrite this as a perfect square, which is just x minus 4, half of the x term. All right? And we do the same thing with the y's. We got those, and it's y plus half of the y term, 2, equals 36, which is just combining like terms right there. All right? And now we have this in standard form. We can see, okay, here's h, here's k, here's the radius squared. All right? Now, there it is. So h is 4, because remember, this is a minus h, so it's going to look opposite. All right? So h is 4. Rewriting this as y minus k, so k is -2, and then r is going to be 6, because it's the square root of 36. All right? So our center is at 4, -2. The radius is 6. So then we can graph the circle. Use a compass, makes it nice. That way you can get an even circle. The radius is the same all the way around. All right? Plot your center, and we draw the circle. All right. So what I want you to do, pause the video, work out these two here, then come back and check your work. All right, let's see how you did. Number 3, you should have had the standard equation there. And number 4, here's the graph, here's what you should come up with. All right. If that's what you came up with, great. Skip ahead. If not, here's how you work it out. So number 3, we have distance formula. We have the center, we have a point on the circle, we need to come up with the radius. So the radius, we're just going to use the distance formula. It's going to look like this. Plug it in. X and Y, those come from the point on the circle. H and K, that's your center. And that, you can really just type it into your calculator. And there is R, so you plug that back in, and there's your equation. All right? So not too bad. Number 4, here we go. We got this loveliness, and we need to make it standard equation. Remember, we do this with completing the square. So we start with the equation it gave us. Move the 9 to the other side, so we're going to subtract 9, and we're going to group the x's together, and we're going to group the y's together. Now we do the complete the square. So we're going to take 1/2 of the -8 and square it. So half of 8 is -8 is 4. -4 squared is 16. Positive 16. Half of 6y. Half of the 6 is 3. And 3 squared is 9. So we're going to add 16 to both sides. We're going to add 9 to both sides. Then we rewrite these as perfect squares. So x minus half of the 8, so 4, because it's negative 8, and then y and half of the 6, so y plus 3. So we wrote those as perfect squares, and we combine like terms, simplify that, we have 16. Remember, this is r squared, and we need a radius. So here we have h is 4, k is negative 3, because remember, it's backwards from what it looks like, because it's minus a negative 3 to get the positive. And then r is the square root of 16, which is 4. All right? So, not too bad. Okay, so what we want to do here is to either prove or disprove that the point square root of 2 is on a circle centered at the origin and that has this point on it. All right? So, looking at this, we have to figure, we've got the center, we need the radius. All right? So, to find the radius, we're going to do the distance formula again, which really is pretty easy since it's on the x-axis and centered on the origin. So we know our distance is going to be 2. So there's our radius, 2. And now what we're going to do is plug this in. Now that we have our equation, plug this in to our equation, plug that in for x and y, and see if this also has a radius of 2. If this is 2 units from the center, then it's also on the circle. So we plug it in, and the distance formula says, hey, that came out to 2. So this has a radius of 2. The other one has a radius of 2. They have the same radius. And therefore, they are both on the same circle. So it works. So what I want you to do is prove or disprove that the point 1 square root of 5 is on a circle centered at the origin, and that contains this point. All right, pause the video, work that out, then come back and check it. All right, let's see how you did. Here we go. Looking at this, we have a radius of 1. It's centered on the origin. This is 1 unit from the radius. 1 unit from the origin. So now we're going to do the distance formula with this point from the origin. So h and k are 0. And we come up with square root of 6. And the square root of 6 is not 1. Therefore, this point is not on the circle because it's too far away. Right? It doesn't have the same radius. So, no good. All right. Last thing. Epicenter of an earthquake is the point on the Earth's surface directly above the earthquake's origin. And we can use a seismograph to determine the distance to the epicenter of an earthquake. And what you need to do is use 3 different seismographs to locate the earthquake's epicenter. So what we're going to do is use the seismograph readings from these 3 locations to find the epicenter of an earthquake. All right. So first, set all points. What we need, our answer, is going to be the points that are equidistant. Right. So the epicenter is on the following circles. Circle A, centered at the point -2, 2.5, with a radius of 7. This circle, right, because we know it's 7 miles away, but we don't know where it is. This one's 4 miles away, but we don't know which direction. So it's going to be anywhere on this circle, and it could be anywhere on this circle. So to find the epicenter, we put all 3 circles on the graph, on the coordinate plane, like so, and our epicenter is where they all intersect. Right there. All right. Here's what it could be for circle B. Here's what it could be for circle C. A. Here's what it could be for circle C. And that's where it all intersect together. All right. Okay. So last question. Why do we need 3 seismographs to do this? All right. The reason we need 3 is because if I only have 2 of them, circle 1, circle 2, they intersect at 2 places, so that doesn't tell you where it is. You have to have that 3rd circle so you get an intersection between all 3 of them. All right? So to get an intersection that locates just 1 intersection, you have to have 3 circles. If you only have 2, then you don't know where it is. All right? And that is circles on a coordinate grid. Standard equation for a circle. Remember, the stuff in parentheses is going to look backwards. All right? And hopefully that helps, and I'll see you next time.